Hello and hi everyone. We are from Group 9 for the Discrete Signal System project. Our class is BET S22 and my name is GHUGAAN KANIGASALAN.
My name is Nathan Reza, anak James BAE'E.
My name is HIDAYAH binti FAIZAL.
My name is Hasyim Rafee.
Okay, welcome guys. Today we're going to discuss about our project for the Discrete Signal System, which is named Image Processing. For this image processing, we got 3 effects. So, what do you guys think? Which task are you guys gonna do?
I think I will be volunteering for task 1, which is the fast Fourier transform. I think I'll take.
Okay, good idea. How about Ashik?
So, I think I take to task 3 about the Laplacian of transform.
Okay. Hidayah?
Then I will do task 2,
Okay.
which is Gaussian blur.
Okay, since Gaussian blur got a lot of coding, I will help you with that. Okay, are you okay? Okay, thank you.
So, dia punya parameter ni setiap parameter kau ubah. Setiap parameter yang kau ubah yang Laplacian log of Gaussian. Yang membezakan benda yang benda ni dengan benda ni. So, dia akan filterkan setiap filter. Ni gambar original dia akan jadi original.
Kalau kita tukar kat sini kita balik kan.
Okay, dah cukup lah. Tak tak lah.
Kalau run semua dia akan buat semua tu sekali.
Kalau ada semua kan aku akan dapat sepak miss image tu lebih kalau lebih tinggi tu satu dia Gaussian tak kan dia smooth dia nak smoothkan
Kau edit video ni dulu kan, kau campur-campurkan 50 minit.
Hello and a very good day to our lecturer, Dr. Noor Azlan. And my name is Dr. RANDALL, anak James BAE'E, matric card number B0822101171. And I am responsible to task number 1. First of all, we need to put the command clear all, close all, and CLC to clear all the text from the command window. And then to read the image, we put the coding for IM data GPU array in Beet, and we put the file path into the space here, and then we create a figure here. After that, we need to display the original the image, and we use the subplot 231 to represent the image data to show on the first one. Here is the image. Then after that, we convert the image to gray it, and then after that we show it again to the second data. Next, we get the Fourier transform, and then we transform the Fourier and we display it again on the third image. On the Fourier transform, the image is completely black because that's the result, and after that, to get back the result, we need to center it, and then the command we use to get the center is FF shift, and then we display it again, and then we apply the log to get a more clearer image, and then we display it on the fifth image, and lastly we reconstruct the image using the previous application that we have, that is log and center shift, and then after that we display on the last part. Thank you.
My name is Noor Hidayah binti FAIZAL. My matric number is B0822104443. I will explain about task 2, which is about Gaussian blur. In the first line, image read is a function used to read an image file from disk. File.jpg is the file path and name of the image to read. This path indicates that the image file name .jpg is located in the specified directory on the C drive. The output of this function is assigned to the variable I, which stands for the image. Next, iBlur1 applies Gaussian blurring to the image I using a standard deviation of 2. The image Gaussian filter function takes two arguments. First, the image to be blurred and the standard deviation of 2 in this case. For iBlur2, it is similarly to iBlur1, which using a larger standard deviation of 4, while iBlur3 using an even larger standard deviation of 8. For subplot 331, specify to create a grid of subplot with 3 rows and 3 columns and select the first subplot on top left position. Then image show function is used to display an image stored in the variable I. For the title function, it's used to set a title for the current subplot in the figure. It sets the title of the first subplot to original image. For subplot 332, specify that the grid and select the second subplot on top center position. Image show function is displaying the image stored in variable iBlur1, which represents a smooth version of the original image I. For the title, it sets to smooth image sigma equals to 2, where sigma represents the standard deviation used for blurring. For subplot 333 are same as subplot 332, which the grid selected the third subplot on top right position. Image show displaying the image stored in the variable iBlur2. For the title, it sets to smooth image sigma equals to 4. Lastly, for subplot 334, selected the fourth subplot on middle left position. Image show function display the image stored in variable iBlur3, and for the title, it sets to smooth image sigma equals to 8, indicating that the displayed image is the result of smoothing the original image with a standard deviation of 8.
Hello and good morning everyone. My name is GHUGAAN KANIGASALAN, metric card number B0822102004. And for our project, I help with the coding, which is Gaussian filter. So as you can see from line 23 starts my coding. So Gaussian filter is an image blur effect for the original image, which affects using the sigma value, which is different standard deviation for x and y directions. It also displays in subplot arrangement. So starting from line 24, we can see that we have 4 images which are x1, x2, y1, y2, and the images filter is the one that gives the filter effect, which is Gaussian. And also the image is I, and these two values are x and y. So for the first one there are 4, 3, for second image there are 8, 2, third image 1, 7, and also the last image 1, 8. So as you can see in line 29, subplot 5, which gives blur effect for image 1 in x-axis of 4 and y-axis of 3. And for the second image, we can see we use subplot number 6, which gives a blur effect for the image 2 using x value 8, y value 2. And for the seventh subplot, we can see the third image gives the blur effect on x-axis 1 and y-axis for 7. And the 8th subplot gives the blur effect for image 4, which is x value 1 and y value 8. And for the last one, this is a region of interest showing the comparison of an original and smoothed image, which results in sky in filter image. So the last image is just comparison of an original image until it becomes a smoothed image. So Gaussian filter is just blurring the effect of an original to a more smoothed image. Thank you.
Hi and hello, my name is Hasyim Rafee. Card matrix number is B0822102005. So here the task is given is task 3. for edge detection. For the first line, this is I equals to GPU array. I'm read users and shim DSS, that is the file of path. So the GPU array is the for run this MATLAB code, it's used the GPU. For the subplot 231, I'm show title original image. So first the output will show the original image first for the subplot 2y3 x-axis and y the position. So hash equal to f special log 70.4 is the edge detection. So for the line of 4 is hash equals to f specials log 70.4. For the f special is a two-dimensional filter for size of filter of the log, and the sigma is a standard deviation as a positive number. In the line of 9, there was imfilter, is a multi-dimensional array of image to be filtered with multi-dimensional filter that specify as ND array of data type double return value as I. So here are the value for each subplot, that is 0.6, 0.7, 0.8, 0.9 and 1.0. I'm using the 5 different value of standard deviation to show the differences of the image. So if I run this code, it will show the original image from my subplot and others edge detection followed by their code their subplot code. So if the edge detection, or if the highest of sigma value, the harder it to detect the edges. So for 0.6, it's been harder to detect until the 1.0 sigma.
Okay, in conclusion, we have learned a lot actually, and especially on task 1, task 2 and task 3 also. But however, on task 1 we have understand to do fast Fourier transform on MATLAB and what it has been done. And after fast Fourier has been applied, it become black, and then we need to reconstruct it. Okay, and we have managed to do it.
In task 2, we do about Gaussian blur, which is we insert a value and the output will blur the original image. The largest value and the more value, the more blurring effect on the picture.
So for the log kernel in the task 3, we did the log, that means Laplacian of Gaussian. So we have increasing the parameters of the standard deviation. So the highest the standard deviation, the more we unsee the picture. So meaning that the edges and the details can't see from our eyes. So to conclude this, we understand the Laplacian of Gaussian is the more of standard deviation we increase the parameter, the more we can't see the image. That's all.
So for the second part, task 2, we can see from the Gaussian blur effect, we need to set some standard deviation on the x-axis and y-axis. So this makes the picture blurry effects on the specific parts only. And also there's a transition from a smooth original image to a full smoothened image. This is called the Gaussian blur effect. At the end, we learn a lot about coding in the MATLABs and also the image processing effects, which are explained by my friends just now. Thank you.